Hi friends, good morning. In the last class, we have discussed some problems related to the binomial coefficients. We have done the finite series problems. In this session, we are continuing some other problems related to these concepts. Okay, let us start. See the problem. If the coefficients of 2r plus 4th term and 3r plus 4th term in the expansion of 1 plus x whole power 21 are equal, then we have to find the r value we have to find. Okay, see the solution. See the solution. What is your given expression? What is given expression here? Given that 1 plus x whole to the power of 21. This is the given expression. We have to given the coefficients of 2r plus 4th term and 3r plus 4th term in this expansion are equal. We have to given the coefficients of these two terms are equal in this given expansion. Okay. Now we are writing the term t 2r plus 4th term. T 2r plus 4th term. Now we are writing this one. So that is t 2r plus 3 plus 1. This is the in the form of tr plus 1. That is the general term. Now what is here? The general term, that is the formula. What is tr plus 1? What is the tr plus 1? Is the formula ncr x to the power of n minus r a to the power of r. This is the general term in the binomial expansion. Here we are writing r is 2r plus 3. What is here n? N is 21. That is 21 c 2r plus 3 2r plus 3 ncr into x to the power of r. What is here? X to the power of r. So what is here r? That is 2r plus 3. That is 2r plus 3. That is the tr plus 1 term, that is ncr, that is 21 c 2r plus 3 x to the power of 2r plus 3. That is the term of 2r plus 4th term. That is here we are taken the coefficient. So what is the coefficient here? 21c 2r plus 3. And what is next? The second term, that is the term 3r plus 4th term. 3r plus 4th term. That is now we are writing here 3r plus 3 plus 1. This 4 can be written as 3 plus 1. Now here what is r? R is 3r plus 3. That is, so what is here? ncr. R is here 3r plus 3. 3r plus 3. Here x to the power of 3r plus 3. Here the quotient is 21c 3r plus 3. These coefficients are equal. In these two terms, given that the coefficients are equal, given that that is these two coefficients are equal, 21c 2r plus 3 is equal to 21c 3r plus 3. These two coefficients are equal. So this is in the form ncr is equal to ncs. Then what is the formula? R is equal to s. R is equal to s. Or n is equal to r plus s. R plus s. This is the formula. So ncr is equal to ncs. Then r is equal to s. Or n is equal to r plus s. Okay. Now we are writing r is equal to s. Now we are equating these r is equal to these coefficients. That is 2r plus 3 is equal to 3r plus 3. This 3 will be cancelled. Here 3r is equal to 2r. From that we have taken, this is moving to this side, 3r minus 2r is r. Therefore here r is equal to 0. So one of the r value is 0. And another formula, what is another formula? Or another formula, what is n is equal to r plus s. Here n is 21 is equal to 2r plus 3 plus 3r plus 3. Okay. Now that is equal to 2r plus 3r, that is 5r. 3 plus 3, 6. Here 5r is equal to, here 21 minus 6. So that is 21 minus 6. That is 15. That is 15. Here 5r is equal to 15. Therefore r is equal to 15 by 5. That is 3. So the values of r are r is equal to 0 or r is equal to 3. So these are the values of r. R is, it may be 0 or r is equal to 3. Okay. Another problem. If the coefficients of x to the power of 9, x to the power of 10, x to the power of 11 in the expansion of 1 plus x whole power n are in AP, that is arithmetic progression, then prove that n square minus 41n plus 3398 is equal to 0. Okay, that is the given problem. See the solution. What is the given expression? That is the standard binomial expression. This is given that 1 plus x whole to the power of n. So that can be written as in the sigma notation, sigma NCR x to the power of r. Now we have to given that the coefficients of x to the power of 9, x to the power of 10, x to the power of 11. These are the coefficients we are writing in this expansion. Now the coefficients of x to the power of 9, x to the power of 10, x to the power of 11. The coefficients of x to the power of 9, x power 10, x power 11 in this expansion are in this, the coefficients of x power 9, x power 10, x power 11 in this expansion are in arithmetic progression, that is in AP. That is we are writing the coefficients. What is the coefficient of x to the power of 9? For x to the power of 9 coefficient, r is we are taken 9. That is NC 9, and x to the power 10 coefficient, that is NC 10, that is x to the power of 11 coefficient, that is NC 11. These terms are in AP. That is the coefficients of x power 9, x power 10, x power 11. These are the coefficients. X power 9 coefficient is NC 9, x power 10 coefficient is NC 10, and x power 11 coefficient is NC 11. These terms are in AP. Now we have to prove that. N square minus 41n plus 398 is equal to 0. So if any terms, suppose a comma b comma c are in AP, then what is the property? 2b is equal to a plus c. So this is the property. If any three terms are in AP, then the condition is 2b is equal to a plus c. Now these are the three terms are in AP. Now we are writing, therefore, that is 2 into the middle term NC10 is equal to NC9 plus NC11. Now this NC10 is moving to RHS side, then we are getting 2 is equal to NC9 by NC10 plus NC11 by NC10. Now we are dividing NC10 on both sides. Now this can be written as 2 is equal to 1 by NC10 by NC9 plus this is as it is NC11 by NC10. So here we are using the formula. What is that formula? That is NCR by NCR minus 1. We are already discussing this formula. So that is N minus R plus 1 by R. So we are using this formula here. Here NC10 by NC9. This is R, is 10, r minus 1 is 9. Here NC 11 by NC 10. Here r is 11, r minus 1 is 10. So now we are applying this formula. We are getting that is 2 is equal to here 1 by what is n C10 by NC9, that can be written as n minus r plus 1 by r. Here r is 10. Okay, this is next NC11 by NC10, that is n minus r plus 1 by r. R is here 11. Okay, now we are simplifying this one, that is 2 is equal to, here 10 is moving to numerator, that is n minus 10 minus minus 10 plus 1, that is minus 9. Here n minus that is n minus 11 plus 1, that is minus 10 by 11. Now we are LCM this one. Okay, now we are writing the LCM, that is 2 is equal to, here LCM is 11 into n minus 9. So now here n minus 9, we are multiplying 10 into 11, that is 110, plus here n minus 9 into n minus 10. Now we are writing n minus 9 into n minus 10. Okay. Now we are moving to, this term is LHS side, that is 2 into 11 into n minus now, that is 2 into 11, that is 22 into n minus 9, that is equal to 110, plus here n minus 9 into n minus 10. Okay, now we are multiplying with 22. This is 22 n minus here 22 nines, 9 to 18. So 18 plus 1, that is 19. 198 is equal to 110 here, plus n minus 9 into n minus 10, multiplying with these two terms, n into n square, that is minus 10 minus 9n, minus 19n minus of minus plus 9 into 10, that is 19. Okay, now these terms we are moving to this side. Then we are getting here n square, here n square, here what is minus 19n, here 22n, minus 19 minus 22n, that is minus 41n. Here 19 plus 110, that is 200. 200 here 1 minus 198 is moving to this side, that is plus 198. So here 200 plus 198, that is plus 398 is equal to 0. Now this is the required result. We are getting here n square minus 41n plus 398 is equal to 0. So these are the coefficients x power 9, x power 10, x power 11. These are the coefficients in this expansion are in AP. Then we are getting the result in n, that is n square minus 41n plus 398 is equal to 0. Okay. See the another problem. If 36, 84 and 126 are the three successive coefficients in the expansion of 1 plus x whole power n, then find the value of n. So this is the our problem. See the solution. See the solution. What is the given expression? That is standard binomial expansion. That is given that 1 plus x whole power n. That is the standard binomial expression. So this can be written in the sigma notation. Sigma NCR x to the power of r. Now we have taken three successive coefficients in the expansion. Now we have taken those are given the values 36, 84 and 126. So here we have to taken later three successive coefficients. Now generally we are taken in middle terms. We are taken the three successive terms in this expansion. That is we are taken, that is NCR minus 1, that is given 36, that is say equation 1. Next we are taken this term NCR, that is the value is 84. And we have taken third term quotient, that is NCR plus 1. NCR plus 1, that is given 126. These are the three successive quotients, NCR minus 1, NCR, NCR plus 1. These are the three successive quotients in this binomial expansion. These are the values you had given. So that is 36, 84 and 126. These are the three successive quotients values in the given expansion. Now we have to find the value of n. Now we have to find the value of n using these three equations. Now we are writing equation 2 by equation 1. Now what is equation 1? That is NCR. Equation 2 is LHS NCR. Equation 1 LHS is NCR minus 1. That is equal to 84 by 36. 84 by 36. Okay. So this is we know that the formula NCR by NCR minus 1. So here what is the value of 84 by, that is 36. So that is we are getting here simplifying, then now we are cancelling, that is 12 3s and 12 7s are 84. Now we are in this NCR by NCR minus 1, that is the formula NCR by NCR minus 1, that is equal to n minus r plus 1 by r. We are using this formula here. So that is n minus r plus 1 by r. N minus r plus 1 by r is equal to 7 by 3. Okay. Now we are cross multiplying, that is 3n minus 3r plus 3 is equal to 7r. So this 3 minus 3r is moving to RHS side. Then here 3n plus 3 is equal to 7r plus 3r, that is 10r. From that we are writing r is equal to 3n plus 3 by 10. This is same equation 4. This is a equation 4. From this we are writing r is 3n plus 3 by 10. Okay. Now next we are writing equation 3 by equation 2. Now we are writing equation 3 by equation 2. Okay. What is equation 3? That is NCR plus 1 by NCR plus 1 by NCR is equal to, that is here equation 3 is RHS is 126. 126 by 84. 126 by 84. So what is the value? Okay, see that. So this value is 42 2s, 42 3s. Here NCR plus 1 by NCR, this can be written as this is using like this formula. So here R is R plus 1, N minus R plus N minus R. In the here R is R plus 1 by R. R is here R plus 1. Here NCR by NCR minus 1 formula. That is here R is R plus 1. R minus 1 is R. Now we are writing N minus R plus 1 by R. Here we are writing R is R plus 1. That is equal to 3 by 2. So here N minus R minus 1 and plus 1 will be cancelled. Here N minus R by R plus 1 is equal to 3 by 2. Now we are cross multiplying, then we are getting 2n minus 2r is equal to 3r plus 3. Now this minus 2r moving to this side, then here 2n minus 3, this 3 is moving to LHS side. This is 3r plus 2r, that is 5r. From that we are writing r is equal to 2n minus 3 by 5, that is equation 5. From 4 and 5, LHS are both are same. From 4 and 5 we are writing, from 4 and 5 we are equating RHS. Okay, that is 3n plus 3 by 10 is equal to 2n minus 3 by 5. Here 5 2s are 10. That is 2 is moving to that side. Then here 3n plus 3 is equal to 2 into 2, that is 4n. 2 into 3 6. So that is here 4n, this 3n is moving to that side, and this 6 is moving to this side, that is 6 plus 3, that is here 4n minus 3n is n, therefore n is equal to here 6 plus 3, that is 9. So what is the value of n here? N is equal to 9. So we are finding the value of n, that is we are obtaining here n is equal to 9. Okay. Okay, see the another problem. If second, third, fourth terms in the expansion of a plus x whole to the power of n are respectively 240, 720 and 1080, then find a x n. Now we have to find these values. We have to given these terms are, so second term and third term and fourth term are given that. Okay, see the solution. See the solution. What is the given expression here? Given that our given expression is a plus x whole to the power of n. A plus x whole to the power of n. That is given expression. And second term, third term, fourth term in these expansions are given the values. Okay, now we are writing second term, that is t2. That is the second term, that is t2. Second term is t2. This t2 can be written as t1 plus 1. That is in the form of tr plus 1. Here what is r is 1. Here ncr. R is here 1. Into first term, what is first term? A to the power of n minus 1. Into second term, that is x to the power of 1. This value is given, this term value is given 240. That is given 240. Okay, that is the second term. Now we are given the third term. What is third term? T3. That can be written as T2 plus 1. That is NC2. Here R is 2. And what is first term? That is A to the power of n minus 2 into second term to the power of R. That is 2. That value is given 720. That value is given 720. That is equation 2. And the fourth term is T4. That is T4 can be written as T3 plus 1. Here R is 3. NC3 into A to the power of n minus 3 into x to the power of R. R is 3. That value is 1080. That is same equation 3. These are given. We have to find a value, x value and n value. Okay. Now we have to find these three values, a, x and n values using these relations. Now we have to write here. Now we write equation 2 by equation 1. What is equation 2? This is LHS, that is NC2 a to the power of n minus 2 x square by, in the equation 1 LHS is NC1 a power n minus 1 into x. In RHS equation 2, that is 720. In equation 1, that is 240. This 0 will be cancelled. Okay, here 24 3 times cancel. Okay, that is 24 3, so that is 72. Okay, now we are writing, this is here NC2 by NC1. Here a to the power of, here x square by x, 1x is cancelled. Here a to the power of n minus 2. Here the bases are equal. This is moving to numerator. Then that can be minus n plus 1 into x is equal to 3. So what is here? That is NC2 by NC1. That is using the formula NCR by NCR minus 1. That is n minus 2 plus 1 by 2 into here minus n plus n is cancelled. Here minus 2 plus 1, that is a to the power of minus 1, that is 1 by a. That is we are getting x by a is equal to 3. That can be written as here n minus 2 plus 1, that is n minus 1 by 2 into x by a is equal to 3. That is say equation 4. That is say equation 4. Now we are writing another two relations. Now we are taken here, that is equation 3 by equation 2. Now we are writing equation 3 by equation 2. Okay, that is equation 3 LHS is NC3 a to the power of n minus 3 into x cube by equation 2, that is NC2 a power n minus 2 into x square is equal to, in RHS side, what is equation 3? That is 1080 and this is 720. Okay, these zeros will be cancelled. So if we are writing here, that is NC3 by NC2, here a to the power of n minus 3, here moving to numerator minus n plus 2. Here x cube by x square, that is x is equal to, here 72 3 times will be cancelled. Okay, that is that implies, that is we are getting here 3 by 2. So okay, so after simplifying we are getting that is 3 by 2. Here NC3 by NC2, that is n minus 3 plus 1 by 3. Here NCR by NCR minus 1 formula we are using here. Here minus n and plus n is cancelled. A power minus 3 plus 2, that is a power minus 1, that is x by a is equal to 3 by 2. Okay, now we are writing this equation n minus 3 plus 1, that is n minus 2 by 3, n minus 2 by 3. Here x by a is equal to 3 by 2. n minus 2 by 3 into x by a is equal to 3 by 2. This is same equation 5. Now we are writing 4 by 5. Now we are writing equation 4 by equation 5. Then we are cancelling these x by a terms. We are getting n value. Okay. Now we are writing 4 by 5. What is fourth equation? That is n minus 1 by 2 into x by a by, what is equation 5 LHS? That is n minus 2 by 3 into x by a is equal to, what is equation 4 LHS? That is RHS is 3 by, here equation 5 3 by 2. Okay, so this 3 will be cancelled and x by a will be cancelled. So now we are writing here n minus 1 by 2 is moving to denominator into n minus 2. Here 3 is moving to numerator. This 3 is numerator and this 2 is coming to denominator. That is equal to, here what is 1 by 2? 1 by 1 by 2, that is becomes 2. Okay, that becomes 2. Okay, now we are cross multiplying and simplifying this one. That is 3n minus 3. 3n minus 3 is equal to 2 into 2 4. 4n minus 4 into 2 8. So from that we are 3n is moving to this side, that is 3n minus 4n minus 3n, that is n. Here 8 is moving to this side, that is 8 minus 3. Therefore n is equal to 8 minus 3, that is 5. We are getting the value of n. N is equal to 5. Okay. Now in this case we are getting n value. N is 5. Now we have to find the x value and also a value. Now we are getting n is equal to 5. Now substitute this value n in equation 4. Now we have to substitute. Now substitute n is equal to 5 in equation 4. Now I have to substitute n is equal to 5 in equation 4. What is equation 4? That is n minus 1 by 2. That is 5 minus 1 by 2 into x by a is equal to 3. What is 5 minus 1, that is 4, 4 by 2, 4 by 2, that is 2. 2 into x by a is equal to 3. From that we are writing, x is equal to, that is 3a by 2. Now this 2 by a moving to this side, that is 3a by 2. Here this is the x value. So here this is same equation 6. Okay, now say this is equation 6. So that x is in terms of a, that is 3a by 2. Now we have to substitute n value and x value in equation 1. So what is equation 1? Equation 1 is nc1 a to the power of n minus 1 into x is equal to 240. That is the equation 1. So we know that the n value, that is n is 5, 5c1 into here a to the power of 5 minus 1. Here x is we are writing in terms of a, that is 3a by 2 is equal to 240. From that what is 5c1? That is 5c1 is 5. Here a to the power of 5 minus 1, 4 into here 3 by 2 is the constant into a. Here a to the power of 1 is equal to 240. Okay, here a power 4, a power 1, that is a power 5. Okay, now this 5 will be cancelled. 5, 20, 5, 8, 8 are 40. Okay, so 5, 48 are 240. Okay, now we are writing this is 3 and here 2. Okay, so 3 ones are 3, 3, 16. Okay, so from that here remaining 2 is moving to this side, that is 32. Here we are getting a to the power of 5 is equal to 32. So this 32 can be written as 2 to the power of 5. Here a to the power of 5 is equal to 2 to the power of 5. Here powers are equal. From that we are getting a is equal to 2. Here a is equal to 2. Okay. So now we are substitute this a value in equation 6. This is substitute. Then we are getting x value. What is x here? 3a by 2. That is 3. What is a? A is 2 by 2. This 2 will be cancelled. We are getting x is 3. Okay. Now we are getting n value, x value and a value. Therefore, we are finding the values. Here n is equal to 5 and x is equal to 3 and a is equal to 2. These are required values: a value, x value and n value. Okay, so n is equal to 5 and x is equal to 3 and a is equal to 2. These are the required values. See the next problem. If the coefficients of rth term, r plus 1 term and r plus second term in the expansion of 1 plus x whole power n are in AP, that is arithmetic progression, then prove that n square minus of 4r plus 1 into n plus 4r square minus 2 is equal to 0. That is the proving result. See the solution. Given that, see the solution. What is given expression? That is standard binomial expansion. That is 1 plus x whole to the power of n. So in that we have to give an rth term, r plus 1 term, r plus second term coefficients are in AP. So this is written in the sigma notation, that is NCR x to the power of r. Now we are writing the rth term. So now we are writing the rth term, TR. What is TR? That is T r minus 1, T r minus 1 plus 1. That is we are taken r is r minus 1. We are taken NC r minus 1 x to the power of r minus 1. This is the coefficient of rth term. Next, we are writing r plus 1 term, t r plus 1, we know that that is the general term. Now we are writing ncr x to the power of r. This is the quotient, ncr, that is the quotient of r plus 1th term. Next we are writing the r plus second term, that can be written as r plus 1 plus 1. Here ncr plus 1 x to the power of r plus 1. What is the quotient in the term ncr plus 1? These are the quotients r plus 1, r plus second terms. These are in AP. Given that these are the quotients are in AP. That is ncr minus 1, ncr plus 1 are in AP. These three factors are in AP. Now, if any three factors are in AP, we are already discussing A, B, C are in AP. Then what is the property? 2B is equal to A plus C. We are using that property here. That is 2 into the middle term. That is 2 into NCR is equal to, that is NCR minus 1 plus NCR plus 1. Okay, now we are NCR moving to RHS side, then we are getting here 2 is equal to NCR minus 1 by NCR plus NCR plus 1 by NCR. That can be written as 2 is equal to 1 by NCR by NCR minus 1. This is well known formula. Here NCR plus 1 by NCR. Okay, now we are simplifying this one. See that here using the formula NCR by NCR minus 1. That is here LHS is 2 is equal to 1 by here NCR by NCR minus 1. That is formula N minus R plus 1 by R. N minus R plus 1 by R plus here NCR plus 1 by NCR. Here R is R plus 1. That is N minus R plus 1 by R plus 1. In the second term, R is we are writing R plus 1. Now that is 2 is equal to, here R is moving to numerator, that is R by N minus R plus 1 plus here minus 1 and plus 1 is cancelled. We are getting N minus R by R plus 1. Okay, now we are writing the LCM in RHS side. That is, what is RHS side? That is R plus 1 into N minus R plus 1. Okay, now we are multiplying R into R plus 1 here. Here N minus R into N minus R plus 1. Okay, now this denominator is moving to LHS side, then is multiplying 2 into R plus 1, that is 2R plus 2, that is 2R plus 2 into N minus R plus 1 is equal to, here R into R, that is R square plus R plus we are writing N minus R into N minus R plus 1. Okay, now we are simplifying 2R plus 2 into N minus R plus 1. So here multiplying the 2R, then here 2NR, 2 into N into R minus 2R into R, 2R square plus 2R. We are multiplying by 2R. 2R into N, 2NR, that is minus R into 2R, minus 2R square. Here 2R into 1, that is 2R. Now we are multiplying by 2, that is 2N minus 2R plus 2 is equal to, in RHS side, that is R square plus R. We are multiplying these two terms, N with N square minus NR plus N, and multiplying by minus R, minus NR minus of minus plus R square. Here minus R into 1, that is minus R. Okay, now what are the terms will be cancelled. Here R square, okay, here 2R plus 2r minus 2r will be cancelled. And the remaining terms 2nr, here minus r square plus 2n plus 2. Here r square, here r square, that is 2r square. Now we are writing what is LHS 2nr minus 2r square plus the remaining terms 2n plus 2. This is LHS. And what is RHS? Here r square plus r square, that is 2r square. Here plus r and minus r, the cancel. So next here r square plus r square is 2r square plus n square. Here minus n square minus nr minus 2 nr plus n minus nr minus 2 nr. Here n. Okay, r square that is 2r square plus n square minus 2 nr plus n. Okay, now we are to simplifying this one. So what is our proving result of n square? Now we are writing here n square. Okay, next what are the terms? So this is 2nr, this is 2nr, that is moving to this side, then minus 4nr. Okay, here minus 2r square, here plus 2r square, that is plus 4r square. Minus 2r square is moving to this side, then that is plus 2r square plus 2r square, that is 4r square. Next what is the remaining terms? Here writing n square here, and this also. Okay, next remaining 2n, here 2n, here n. Now here n minus 2n, that is minus n. This 2 is moving to this side, then that is minus 2 is equal to 0. That minus 2 is equal to 0. Now we are writing here n square. So here minus 4nr, here minus n. So minus n is common, then we are getting 4 minus n is common, 4r plus 1 into n. From these two we are getting minus n is common, then we are getting 4r plus 1. Okay, then the remaining terms here 4r square, here minus 2, that is minus 2. So this is the required result, that is n square minus of 4r plus 1 into n plus 4r square minus 2 is equal to 0. This is our required result. Okay, this is very important for IP problems, and this formula is used in objective problems. So many problems we are using this formula. So if 3 consecutive terms in the expansion of 1 plus x whole power n are in AP, then what is the condition? That is n square minus of 4r plus 1 into n plus 4r square minus 2 is equal to 0. Okay.